Okay guys, here's that problem that we were going to try and work out at the end of the period, and we ran out of time. So this is just like the lab that we did yesterday when we were trying to find the heat of fusion for the ice. And remember that heat of fusion is the amount of heat in kilojoules that it takes to melt or freeze 1 mole of substance. So there are your units. That's what we're trying to get to. This is also a Q equals negative Q problem. In this case, we're looking at the Q of the water, which is usually what we're looking for, versus the Q of the ice that melted. So for the water, we can see that we have 100 milliliters of water, which is the same thing as 100 grams of water, because the density of water is 1 gram per milliliter. So we're starting with 100 grams of water. We heat the water up to 80 degrees Celsius. So this is our T initial. And then we're going to drop some ice in the water until the temperature lowers to 4 degrees Celsius. So that's our T final. And right now, remember, we're just talking about water. And since we're talking about water, we also know the C is 4.184 joules. So if you do the math for the water, it's going to be 100 times 4.184 times final minus initial, and that's going to be equal to the Q of the ice. So the water is going to lose some heat and the ice is going to gain some heat. So heat is what we're interested in, because that's going to give us a number that is in joules. So I don't have my calculator here, but if you'll go ahead and multiply these numbers, we're going to get some kind of joules. So 400 times 76, so I can't even begin to do that in my head. So go ahead and do your calculation, and you're going to have some number of joules, which is the amount of heat gained by the ice as it melts. So then it just becomes a matter of figuring out this kilojoules per mole. So I'm going to go ahead and divide this by my grams of ice. And so since the volume went up, remember yesterday in the lab that we did, the volume went up a certain amount, and we assumed that that was how much ice had melted. So my grams of ice that melted are going to be 83.7 grams. So now I've got some number of joules per gram of ice that melted. But remember that I want to go to kilojoules per mole. So I've got to translate my joules into kilojoules. We use dimensional analysis for that. That gets rid of the joules. And then I need to get my grams to moles. And this is where we use molar mass. So remember that the molar mass of water, H2O, is 2 hydrogens plus 1 oxygen. We get those numbers from the periodic table, so 18 grams is equal to 1 mole of substance. Our grams cancel, and we're left with units of kilojoules per mole. And so we got some number that's kilojoules per mole. That's my heat of fusion. So after that, the problem just asks us what the percent error is. They give us the accepted value for the heat of fusion is 6.01 kilojoules per mole, and we just do a percent error problem. You guys know how to do that already, but just to review, we have our lab value minus our accepted value divided by our accepted value times 100. That's how we do the percent. Remember, our accepted value is the 6.01. Our lab value is whatever you get when you do that calculation there. All right, that's all there is to it. It's exactly like the lab we did yesterday. I just wanted you to see it one more time in a formal problem.